So this demo shows the integration of our orchestrator, ONOS, and the online planning tool, Net2Plan, which has been done in the Achino project. We will show the Achino application-centric approach that can be used to provision network capacity for a football game. Let us imagine that there is a football game in Madrid, it's La Rojas versus the Red Devils, that we want to watch and control from Brussels. At the stadium, there are drones that are remotely controlled from Brussels. These drones have high-definition video cameras attached to them. To control the drones, we need a low-latency connection, or we might fly the drones into the audience, or even worse, into the players. But they don't need a lot of bandwidth. For the video feeds, we do, however, need high bandwidth, but latency is not very important. The network is shown here at the bottom, with the stadium in Madrid shown to the right side and the controlling TV company to the left side. The optical network is a triangle that goes between Brussels, Madrid, and Trento. The connection between Brussels and Madrid is 2000 kilometers long, which limits our bandwidth to only 1 gigabit per second. The distances between Brussels and Trento and Madrid are only 1500 kilometers. This makes it possible to use 10 gigabit channels here. However, the total distance is 3000 kilometers, which increases the latency. We will try to establish the required connectivity using ONOS, Net2Plan, and the DISME application interface. What you will see uses 7 components that have been developed in Achino. First, the service creation using the DISME interface, the application-centric intents in ONOS, the NetWrap modules and protocol used to synchronize ONOS and Net2Plan, the ONOS Planner plugin for Net2Plan, the Achino application-centric provisioning algorithms in Net2Plan, and finally the extended ONOS null provider, which is capable of creating fake optical networks. We will, unfortunately, not have time for watching any football or piloting any drones. So we will first try to use a non-application-centric approach where the requirements of many applications are combined. We combine the high bandwidth requirements for the video streams with the low latency requirements of the control channel, resulting in a service that needs a bandwidth of 9.6 gigabits per second with a maximum latency of 12 milliseconds. Secondly, we will try the application-centric approach, where the applications are separately handled. There will be one low latency, low bandwidth connection, and one high bandwidth, high latency connection. We first need to create our fake optical network, then synchronize the databases of ONOS and Net2Plan. The applications then issue a request, which creates an ONOS app-centric intent, which in turn is tracked by the NetWrap ONOS application, which then transfers it to Net2Plan. In Net2Plan, the Achino algorithms try to calculate a multi-layer path and send it to ONOS for establishment. Okay, let's look at the different pieces. Here is the ONOS web-based GUI, which at the moment is not very interesting as there is no network connected. We also have the ONOS Planner and Net2Plan plugin, which so far is also empty. Finally, we have the graphical client for the DISME application interface. Let's make it more interesting by faking a network by configuring the null provider and connecting Net2Plan to ONOS. Null provider is configured by a script which should shortly create a network. Okay, now that the network has been created, let's have a closer look at the Madrid node. In Madrid, we can see 2 packet devices has been created. First, a switch, which connects the drones, and a router, which is connected to the optical network. The optical network consists of 3 optical transponders with different capacity and color, and 2 optical components which form a disaggregated ROADM. We can also view this network in a layered mode. Here we can see the IP layer on top and the optical layer at the bottom. You can see that no links are available in the IP layer between the nodes. Let's look at Net2Plan. In Net2Plan, the topology has been synchronized with certain modifications to make it compatible between the both. We can see the optical topology here and the packet topology here. For each layer we can see the nodes. So for example, node 7. We can see the links between the nodes and the demands that constitute the services. So far empty. Let's start by creating our first non-application centric service. To do that, we need to load our connection points that have been generated by the null provider, which determines where in the network we are allowed to connect. Let's see that it loaded correctly. Yes. We can now create our service. We name the service NoApp and the intent connection as video and control. This goes from the drones in Madrid to the control in Brussels. It requires 9.6 gigabits of bandwidth and 12 milliseconds of latency. We save it and submit it to ONOS. Now, looking at ONOS, not much has happened. Let's look at the list of intents. Here we can see that an application-centric intent has been created, but has failed to install. This is because Net2Plan was not able to find a path that can provide both the high bandwidth and the low latency. Let's try again with the application-centric approach. Let's create a new service called app-centric. And this time we create the streams separately. First we create a video stream from Madrid to Brussels, bandwidth 9.5 gigabit and a latency of say 50 milliseconds. We save that and we also create a intent for the control channel, also between Madrid and Brussels, with a bandwidth of only 100 megabit, but a latency of 12 milliseconds. We save that and commit. We can see that now many things have happened. Several demands have been created and established. For example, we have a 1 gigabit connection created between Madrid and Brussels for the low latency traffic, and Net2Plan has found routes to establish 10 gigabit connections, first between Madrid and Trento, and then from Trento to Brussels. On the IP layer, this has resulted in 3 new links. That first is used by the low latency connection, and secondly by the high bandwidth connection. In ONOS, we can see that 3 new links have appeared as well on the IP layer between Madrid, Brussels and Trento and Madrid. We can see that these are also visible more clearly in the layered visualization. Looking at each intent, we can see that the ones from DISME are still here, with the two new ones created for the individual services, and with several intents created to serve the optical routes created by Net2Plan. We can see these more clearly by highlighting them. So for example, this is the one going from Madrid to Trento. Here's another one going from Trento to Madrid. We can also see the IP layer intents, this one providing the short low latency connection from Madrid to Brussels. Finally, in the DISM interface, we can see the status of our services. The first one, the no app, is not working, and the app-centric has been installed successfully.